Alright, so our objective today is to continue to learn about topographic maps. Specifically today, we're going to look at weathering, erosion, and deposition. So on Monday, we learned about topographic maps. We talked a little bit about the plate tectonics and how they're related to the topographic map that we saw on Monday. Now we're going to look at weathering, erosion, deposition, because weathering, erosion, deposition changes landforms. It changes the features of the land. So if it changes the feature of the land, you are going to see those differences in the topographic map. So our essential question is the same as Monday, which is how do topographic maps show land features created by plate tectonics and WED, weathering, erosion, deposition. So you are going to do and take notes, or continue to take notes, on the same page as Monday, which should be 135, thank you. Okay, it's the same essential question, that's why you're adding to it. So we started the notes on Monday talking about topographic maps. Okay? And then you drew a topographic map, and then you should have put something on there about how that was an island, and that island was possibly created by what type of boundaries? Oceanic what?
Oceanic,
convergent or divergent. Very good. So that shows us that plate tectonics makes land features we can see it in the topographic map. Now we're going to look at weathering and erosion and how that could change land features. So we're going to look at a PowerPoint. So you're taking notes over the PowerPoint on the different ways that land changes due to weathering, erosion, and deposition. So when we talk about WED, we're talking about weathering. And what is weathering? Breaking down. Okay? So it's the breaking down, wearing away of rock. So when we talk about weathering, it's the breaking down, wearing away of rock. Really, all I would put is weathering, and what are the key words there? Breaking down. That's all I would write. I wouldn't write anything else. Okay? What does the E stand for?
Erosion.
Erosion. What is erosion? Transporting or moving. Okay? So erosion is, after it breaks down, those pieces go somewhere else. That movement of those pieces, that movement of those sediments is considered erosion. Okay? And erosion can occur by either water, wind, or glaciers. And then D stands for deposition. And basically, the first word there is deposit. What does deposit mean?
To drop off.
To drop off. If you deposit money in the bank, don't you drop off money in the bank?
Yeah.
Okay? Deposition, to drop off, or the dropping off of sediments. So, weathering, it breaks down. There's two different types of weathering, physical and chemical. Okay? Or mechanical. Sometimes the physical they call it mechanical. Okay? And once those pieces break, those sediments go somewhere else through erosion, and then wherever they end up is considered deposition. So, weathering is a destructive force because it destroys something. Deposition is a constructive force because it's building something or creating something that's left behind. So, let's look at different types of weathering. Like I said, there are two types of weathering. Mechanical, which can also be called physical, and chemical. So mechanical weathering, water is a way to create mechanical weathering. If you look, water will carry rocks, obviously heavy rocks, not so heavy rocks, and when those rocks hit each other, they break away in the adjoining rocks. So, whenever you have mechanical weathering due to this, what you start having is these rocks that are smoother. And they're smoother because the hitting of rocks and rocks and rocks eventually smooths them out. So, if we look at a topographic map, we look at the topographic map from Monday, okay? One of the observations that y'all made was that the edges were very jaggedy. It wasn't very smooth, right? So, let's say I gave you another topographic map, and it was smoother. So it's almost like oval shape, and all of them were oval shape. So it's a very smooth hill, or a smooth mountain. And I ask you the question, those two mountains, it's the same mountain. And I give you no pictures, I just give you those two topographic maps. And I say, which one is the oldest topographic map? Would it be the jagged one, or would it be the smooth one?
Jagged.
Why the jagged, Ivan?
Because it gets smoother over time.
Very good. It gets smoother over time because of weathering, right? So, the more jagged a rock is, basically, the younger it is. Okay? The more smooth, the older. Because these have been hit and hit and hit over and over and over and over and over again. So these are older rocks. When they're jagged, they're new rocks. Because it just broke off. Okay? So if I take this big piece of rock and I break it, right? Take this big piece of rock and I break it. So I have two pieces. But I take those rocks and over time I keep hitting them over and over and over and over and over again. They're going to smooth out, right? Okay? So it took a time for that to occur. So when you look at rocks, you can tell somewhat, age-wise, by looking at the jaggedness. Okay? If it's really jaggedy, it's newer. If it's smoother, it's older. Okay, yes, question?
What question did you ask?
I'm sorry?
What question did you ask before?
What question?
Yeah, like, what led you to jagged? You said jagged was
Yeah, you said jagged was oldest.
Yeah.
Oh, sorry.
That's why you guys told Ivan. I'm like, what?
I apologize. I apologize. I apologize. Yes, you're right. Yes, the smoother one is the older one. Okay? No. It's the same mountain. I think I said which one is the oldest picture.
Oh.
I said which one's the oldest picture.
Really?
Yeah.
You said old.
It's because it's the same mountain. That's why it was Ivan's. That's why it's Ivan's answer. Because I said if these two are the same mountain,
Oh.
which one is the oldest picture? The oldest picture would have been the jagged one. That's why Ivan's correct. Now, if it's two different mountains, then the oldest mountain is the smooth one. But since I'm talking about the same one, because they'll trick you like that, and they'll say this is the same place. If it's the same place, which one is the oldest picture or which one's the newest picture?
How is the jagged one older?
Because it's before speed.
Because it was a long time ago. I took that picture a long time ago, so that's the oldest picture. Do you see where I'm getting at?
Like black and white and then.
Yes. Yeah, if I have a picture of the same thing, well, you really can't because it would be black and white. So let's change it.
Yeah.
All right. So that's why the answer was Ivan's answer, because I said the picture, not the mountain. They're the same mountain. All right. So they smooth out because of the rocks breaking. So let's look at what happens as water moves. So looking at this animation, we can see that over time, that's a waterfall. So water is moving. Well, that water is moving, it's also taking rocks. So all those rocks are hitting this bottom rock. So over time, they weather away, and it gets broken, it gets broken, it gets broken. So what's happening to the waterfall?
Waterfall getting back.
It's moving back. So you're going to see some of that back movement because of the fact that it's breaking things apart. So here's a different one. So over time, water runs, and as it runs, it starts kind of eating away, and it kind of moves back. Okay? Obviously not that fast. It is a slow process. So looking at these two, once again, same waterfall, the same waterfall. Just taken at different times. So which one was taken recently? Was a recent picture?
The other one, that's iPhone 2.
This one?
Yes.
Okay,
That was a
this
long
one.
time ago because that was new. I mean, that was a long time
because
ago.
it has moved back. If you look at this, you see this right here? It's a little up closer.
That was
Okay.
recent.
That has moved back.
The left one was recent.
The right one's
The right one.
The left, the right one would be a long time ago.
The left one.
No, this is
No,
newer
because remember, if we
Yes,
look at
same
the
picture.
animation, what happens to the top? It gets pushed back.
Yeah, and the right one looks like is it
It
closer
looks like
or
it's
further
from a
apart?
different angle.
Because like the left one, you can see like more of the trees are down because on the river, and the right side looks like there's more trees.
Is it from the same
But
angle or?
you're not looking at the trees. You're looking at where is the waterfall starting.
That's a pretty
But it's coming down more from the.
You're looking at where the waterfall is starting.
This one looks a lot closer than that one though. Because if you think
Look
about
at
it,
where
that
the
part,
waterfall is starting. Look at this right here, compared to this right here.
they're from different angles though.
Well, that's what I meant. I mean, if there's different angles, then how am I supposed to know? I mean, I thought they were from the same point
Sorry,
of view.
it's not from the
That's-
same angle.
Once again, is obviously a teacher can't go in and 100 years later take the same picture.
Well, I don't know.
Really? You don't know that a teacher can't go in and take the same picture 100 years later?
Time travel.
They're gonna be dead.
They should just do longitudinal latitude.
So
exactly.
if you look at that, from that perception, if you assume that it's the same place, the one on the right has the waterfall back much more. Yes or no?
Yes.
Okay. So according to our thing right here, if you look at this animation, what is happening to the waterfall?
It's going back.
It's pushing back. So if you assume that this picture was taken and the same point of view, and you're right, it could be the different point of view. But if you assume that it's the same point of view, by looking at the fact that the waterfall was moving back, which one is the newer picture? The one on the right. Now, once again, from looking at and assuming that it's the same exact point of view, this part in the back looks like it's farther back than this one, which means that over time it has weathered and pushed the river back. And the waterfall has moved back. Correct?
Yeah.
Now, once again, you're assuming that it's the same point of view,
Yeah.
and we're assuming.
So the
But
one-
sometimes you have to
Explain
make
about
assumptions
the
to be
units.
able to look at
so if
what it is.
Every time you're comparing two pictures, the one that's moved back the most is the newest one, and the one that's moved forward.
Yes, yes. If you're looking at waterfalls.
Because it looks smaller, so I thought it was the same,
Same
like
picture.
same point. So I thought it was like this one was.
I am gonna say one thing. Who said that? Who said they thought it was the same picture? You, Mason?
Oh.
Yeah.
I wanna show you something, just cause, and I haven't seen this.
They cracked it.
Look right here. Look at that, and look at that. It's exactly the same.
But when it looks closer, I was like.
Yeah.
It's just a
it's
different
the same
angle.
exact-
That's what we're saying,
but
but
see,
you
look,
can't really, it's
I
hard
mean,
to
you
tell.
can tell,
what
it does
it's
look like that one.
But it looked like
But-
the left one was pushed back more. That's why I thought it looked smaller.
That is wild.
Yeah.
I'm gonna interrupt one. Tomorrow for the benchmark, what has Miss, M told
Going
you?
back here.
So, not taking the benchmark, yes, taking it?
Yeah, no, they're not taking it.
Perfect.
From what I heard, they're not taking it. We have four
4 sections.
sections. She has the groups.
Y'all have a group, okay.
She told it
Yeah.
where we
Go
go.
to Miss F.
She told you where to go to?
We're gonna.
She told y'all where to go to. Oh,
Come over here.
Yeah.
you know,
Geometry.
I'll look at the list.
'Cause I
What,
actually looked
what
at
did
it
Mr.
and
Myers
I-
say about the geometry?
The geometry kids, what we'll do is we'll mix y'all in with the algebra kids. Because they're not taking it either. Okay, perfect. Sorry to interrupt.
Yeah, no, no.
It is so neat.
And the four classes will be in.
All right.
Whoa, you can see.
So if we look at this, we can see this is another example of mechanical weather because of water. That land really was supposed to, or used to be all the way out there. It's not any longer because waves come in and break it down. If we look at this, this down here used to be up there. But once again, you get waves come in and they break it down. Now here's my question. why do you think that that wasn't broken down exactly the same as this if the water's sitting exactly the same way?
Not sand in this rock. I don't know.
But it's sand now because it has been broken down to sand. It used to be rock. Why is it that the rock that was over here on this side broke down faster than the rock that's there? Why do you think, what are some examples of why do you think that could happen? Jose?
Maybe the one on the beach was bigger, less tall, so they got hit more by the water.
It used to be the same.
Oh,
I think.
What do you think, Jasmine? That area could have been older, okay, Manar?
you would have said plants.
Yeah, well, I guess that those, like,
How
well,
do you know
that, there was
how
only
big
one
is
piece
Because
of
you
that.
already said it like 4 times.
No, I'm saying, if it all, because the ocean's there, so it's gonna get hit by water regardless.
I was thinking like tide or something.
Think about, are rocks made exactly, if I take
Oh,
a big chunk of rock, is the rock made, the entire thing,
So it's
made
dense
exactly
rock.
the same
Yeah,
thing?
it's different, thickness and.
Dense.
Different minerals.
Different minerals.
Oh,
Now, are all minerals the same hardness?
no.
So it could be that this side of this area, of this landmass, had minerals that were softer, so if they're softer, wouldn't they get broken down faster? Okay? That's why you end up seeing holes within things, because of the fact that not the entire landmass is made of the exact same minerals, there's different mixtures. And some minerals are softer than others.
Whoa.
Like,
Looks like the
see
ocean.
right here? This used to be a big landmass, but here now you have a hole.
Maybe those
Maybe
minerals
it's
are
the
weaker.
fall.
Precisely. Those
Yeah.
minerals were a lot softer. Alright. So one way of mechanical weathering is water. Another way is wind. Still mechanical weathering. And the reason for it is because whenever wind starts blowing sand around, that sand basically becomes like sandpaper. What can you do with sandpaper?
You could like grind things down to.
Okay, you grind things down and you smooth it down, right? You break it down. Okay? That's what sandpaper's for. So mechanical weathering and with sand, or with basically wind, is basically just that. Is the fact that the sand is sanding everything down.
So it's not specifically the wind.
Not basically, no, because the wind is actually moving that sand. Same thing with water.
Yeah.
Water's moving the sediment or the rock that's hitting everything else. Okay? So same thing right here. So why do I have this hole? Because this middle part probably had,
Yes. Tougher minerals.
okay, less tough minerals, which means softer minerals.
That's so pretty.
That is.
Alright, the other thing, ice wedging. Ice can go through mechanical weathering. Obviously, rocks aren't smooth and have little cracks, correct?
Yes.
Alright, so if it has a little crack, water gets in there, and we don't see this a lot around here because we don't have a lot of freezing temperatures, but they see it a lot up north. Water goes in there, and when it freezes, it expands. You know that because I'm sure at one time or another you left the Coke in the freezer, and it exploded on you. It didn't explode on you. It didn't explode on you because of gas. It exploded on you because the water got solid, and water in its solid phase expands because of the structure that it takes. Therefore, it increased the pressure and exploded. Well, what happens with ice wedging is you have water, it expands, and it makes that hole bigger. And then more water, it expands, makes that hole bigger, eventually breaking that piece off. Yes?
It's probably like something dumb, but would it be like, say you could have more water like that, say your water, you freeze it, it expands, and then you melt it, and then do it again and again and again. Would you get more water, or would it be the same?
It's saying.
I just want to know.
It expands, okay. The reason it expands is not because you get more water. It expands because, remember we talked about water and we talked about molecules, right?
Yep.
Water molecules. So, they're moving around, they're liquid, right? Now, usually, whenever a liquid goes into a solid form, remember the particles get really, really close together and they vibrate in place. Okay. In some solids, which are called crystalline solids, instead of going from this to this, they go from this to this. They expand. The molecules, instead of getting really, really close together, they solidify, but they solidify in geometric shapes.
Oh, so
Okay.
they want to
In
be
cubes.
like a cube.
Yes, so there's more space. That's why ice is less dense than water. Because since there's more space in between the particles, it is less dense. So, and I know this is besides the point, but it's good to know.
I was thinking you probably get like.
Oh,
So,
Is this
whenever you have particles, so let's say these are water molecules. So, in a liquid, remember they just kind of move around all which way, right? Alright. When they solidify in a cube,
Cube-like form?
cube-like form.
Oh.
What makes them
So
want to be a
this
cube?
empty
They
space,
want to be cubes.
that empty space basically allows them to be less dense. And since now there's less space, that's why it expands, is because it's becoming this geometric form. Okay? That's why liquid does, that's why water does that. And there are other liquids that, or compounds that do that. But once again, they're called crystalline solids. And you get crystals. So anything that you have crystals is basically because they're making a geometric shape or form. Yes?
And they, say for any crystal or ice, do they always have to be, cube?
No. Any geometric shape.
Like triangles.
Yeah, there's diamond ones.
Yeah, diamond.
That's how you get different gems. Yes?
Is this much faster than the other ones?
The ice one?
Yeah,
Yeah.
way faster.
Well, if you have a lot of freezes, yes, it can be. Alright, glacier, obviously, once again, you have an ice. Now, what people don't know is they think that glacier is just this big sheet of ice and it stays there. It doesn't stay there, it moves. It's basically like a frozen river, okay? So this frozen river is moving down towards the area. So when it does that, it breaks things apart as it moves down. Usually, if you end up looking at a glacier, you're going to see that there's like this U shape. That U shape is formed, or that valley is formed because this glacier moved in. Just like a river. Okay, rivers kind of tend to leave behind a valley, a canyon, and it's because of that water moving through.
U-shape.
U-shape. Okay. Plants can also do mechanical weathering because the roots are breaking the pieces down. And then we move into chemical weathering. Chemical weathering has to do with the decomposition of minerals. Okay? Now, specific example, you don't want you to put your notes. A specific example of chemical weathering is acid rain.
Ooh, I got it right.
And the second one is mineral deposits on limestone.
Like the ones in Texas.
Mineral deposits on limestone. So, a river runs through and it cuts limestone. You're going to want to say, oh, river cuts through, that's physical. But the fact that they say limestone, if they specifically say limestone, it's chemical. If you ever see the word limestone, it's going to be chemical. Okay? And the reason for it is because the minerals in the water react to the limestone and chemically weather it away. So, whenever you've seen, have you ever gone to like caves with stalactites and stalagmites in them? That's basically an example of chemical weathering. Okay? So what really happens is what we can see on this animation. These little areas, these caves, you have water that's in there. As the water comes down, the minerals that are left behind start chemically weathering away at the cave, and you start getting the stalactites and stalagmites. So first, the water goes in and breaks it down. That first thing where the water goes in and breaks it down, okay? That first initial thing is physical, but eventually, all those minerals are breaking down the limestone. That part is chemical. So if you see anything about water and limestone, that's always going to be chemical.
So
Yes.
since it breaks it down, could it eventually get to the like where the river's at?
Like
you know,
these?
Yeah, like you know how the water inside could eventually go.
Yeah, yeah. I mean, if you, because you also have to remember that you're going to eventually still continue to get water in here, because whenever it rains, water seeps down into it. So yeah, these get bigger over time, and they can eventually break through to an area.
So what would nothing would happen to the land if it did that? Like, once it
The
goes away?
more holes you have underneath, the less support you have, so eventually you could have a cave in. If you ever gone to any of these, they'll have like boards up, because
Yeah.
they're supporting and making sure you don't have a cave in. So yes, eventually,
They could just fall.
once these get too big, this thing is gonna cave in.
That's not bad.
Yes,
'Cause I was-
yes.
Could it ever become flat?
So what become flat?
Like say, you see where that little stream is? Could it ever fall down or be equal? Like the water,
The water that's in the caves, could it ever be equal with the river?
yes.
I'm pretty sure.
It always is equal with the river.
But I mean, like flat, it'll become a different
Come together.
landform.
I mean, look, the water level is always equal with the river.
Oh, I think he means like, will they ever connect?
So will this ever break through and there be a hole here?
Yeah, the whole.
Yeah, you could. I mean, because basically, if things start eating away right here, this joints, you're gonna have a hole there. Yeah, it could happen.
There we go.
Alright, so erosion is basically just moving of those sediments. Now, deposition is leaving those behind. Remember, in deposition, you're making things, right? You're constructing things. So if you see anything like, excuse me, sand dunes, those are constructive.
Delta.
So caves in this?
Ah, almost. But this is the one that I really want you to pay attention to. You better know what the word delta means.
Yeah.
Water?
Okay? No.
Oh my God.
Deposition of
Mouth of the river, land formation.
deposition of sediments at a certain point.
Land formation at the mouth of a
Specifically, a certain
river.
point at the end of a river. Okay? So at the end of a river, going into the ocean, but at the end of a river, going into an ocean, you end up having a delta. The reason you end up having a delta is because that river is taking sediments with it, correct? As it reaches the ocean, it's obviously going to slow down because it has nowhere downwards movement to go. The reason it's moving is because it's going from a high elevation to a low elevation, right? But once it reaches the ocean, it's reached sea level. Is there any more down?
No.
So isn't it going to slow down? So as it slows down, the stuff that it's carrying, especially the heavier stuff, is going to do what? Sink to the bottom, correct? As it sinks to the bottom, it's deposited. And it fans out, and it makes that fan that's called a delta. Now the reason it's called a delta is because delta is a triangle. And it looks, if you kind of looked at it this way, it kind of makes a triangular shape.
It looks like a
Okay?
stone.
A fan shape.
It looks like
So, which is your destructive force?
Weather,
What is your constructive force?
erosion, and deposition.
Specifically deposition, but you can consider erosion too because it's moving to make. Alright? So, any questions on any of this?
No.
Alright. Now,
That's in Russia.
This is the
Right?
easy stuff.
Oh, one question.
yes.
It's like
What? I'm sorry, keep going. Hold on. People need to be quiet over here. Go ahead.
On the delta, do the sediments all up one another?
Yes.
You still look-
But also remember that even though they pile up, you're also having, you still get that little bit of push water coming in. So as things pile up, they can still be moved over. Yes.
Is the delta stable, like, or is it gonna like ever like come out to the ocean? People like go out there?
On a delta, you
Yeah,
can
stay.
go houses on the sides of deltas, not on the delta usually, because you have water coming in. Water's still going through there.
Like stand, like,
It's very unstable sand because it's very, very thin.
does it get kind of like a pond? Is there just like on top of it?
Have you ever gone to Galveston and gone to some of those, the swampy areas?
They're like lily pads, but thicker.
I remember I was like that.
Alright, so, what we're gonna do, I wanna go ahead and give you your special assignment. So you have that, and then you have a worksheet that you need to work on, which I'll give to you, but unfortunately it's gonna become homework, so I don't think you're gonna have time to finish it.
Oh, the video has
Is it gonna be
talking.
Friday?